Dependent sources by Matlab Simulink. So there are four different types of sources can be understand by using Matlab Simulink. Here we have to simulate by taking some examples of dependent sources. First one, current controlled voltage source. It is depending on this is called voltage source. It is depends upon this current. Okay, that's why it is called as a current controlled current voltage source or current dependent voltage source. Current controlled voltage source or current dependent voltage source. And next one, voltage controlled current source. This is called voltage controlled current source. This is indication of arrow is called current source and is depending on voltage drop. That's why it is called as a voltage controlled current source. So by controlling this voltage, and we can control this voltage source. Okay, that's why it's called voltage controlled current source. Next one, current controlled current source. Here 2 IY is depends upon this current source is called 2 IY and it is depends upon IY. That's why it is current controlled current source or current dependent current source. In this circuit, there are two different types of dependent sources. One is current controlled current source and current controlled voltage source. This is 6Ix. Ix is depends upon this 2 ohm resistor. If the resistance is changes, this 6Ix is also changes. Okay, that's why it is called as a current controlled voltage source. If IY changes, this current also changes. That's why it's called as a current controlled current source. Now that's the final last one that is called voltage controlled voltage source. This is called voltage source. It depends upon your voltage, 4 ohm resistor voltage. So 4 ohm resistor, if the resistance changes, this voltage source also changes. So that's why it's called as a voltage controlled voltage source. And then these all four different types of dependent sources can be simulated by using MATLAB Simulink. Open MATLAB Simulink here. First one, what is the first one? What is this first? Uh, this is called first one, current controlled voltage source. It is having five resistors and one voltage source and one dependent source. Take one here, right here. What is this is called voltage source. First one, voltage source. Voltage source. So voltage source. Next, resistors are required. This is called our voltage source. Okay. This is called voltage source. And the next resistors. How many resistors means? 5 resistors. Resistors, type resistor here. Okay. So 5 resistors are required. And copy all these resistors. Copy resistors like this. Here 5 resistors is required like T connection. Press Ctrl R and rotate in this way. Okay. Press Ctrl R and connect this also. 1, 2, 3, 4, 5. 5 resistors. Connect this 5 resistors like this. Like T connection. And then control connect this in this way. Remaining elements. And here, what is the required? That is called first one. What is that first one? Voltage, current controlled voltage source. Right here, current controlled voltage source. Current controlled voltage source. Current controlled voltage source. Current controlled voltage source. So this is called current controlled voltage source. Place here, and then it is depending on what this resistor. Okay. So place here, connect in this way. And this is called source circle. The circle one is called as a source. Current controlled voltage source. The resistors, these are all resistor. One, what is that one? Ground is required, that is called here electrical reference. Electrical reference. Take electrical reference, place here electrical reference, like this, electrical reference. And take one solver configuration also. Solver configuration. Solver configuration. Solver configuration. Okay, connect here solver configuration. And this is called our DC voltage source. And where it depends upon this current controlled voltage source. It depends upon 5 ohm resistor. Here 5 ohm resistor. That's why uh, connect in series with 5 ohm resistor. First change the values of resistance. This is called 20 voltage source. 20. You open this voltage source, and right here will by open the voltage. While opening this voltage source, it shows like this. Okay, so take another voltage source. Voltage source, DC voltage source, another type of DC voltage source. Don't select this type of voltage source for this connection because of this used in Simulink. Okay, this is called Simscapes elements. Okay, right here, take another value of our DC voltage source. Select this type of DC voltage source. This voltage source is having this AC voltage, peak amplitude, AC voltage, phase shift. These all are not required. Only DC magnitude is required, constant and voltage. Okay, so that's why I delete this and place here and open this DC voltage source. Here, what is the DC voltage? 20 volts. That's why right here voltage source is called 20. Then okay, close. This is the resistance, and then DC voltage source. The next similar way we have to change the values of resistances. This is called DC voltage source 20, and the next 5 ohms, 2 ohms. So this resistance of this resistor is called 2 ohms. Okay, then close. And here what is the resistance? 20 ohms. And here what is the resistance? 5 ohms. Change 5 ohms. And this resistance also. The resistance is called 10 ohms. And this resistance is called last one. This resistance is called 2 ohms. Okay. Like this, the DC voltage source is having 20 volts. Okay. 20 voltage source. This is the 20 volts. DC voltage source is having, what is the voltage here? 20 volts. Next, what is the resistance here? 2 ohms. Right here, like that's why right here 2 ohms. Then what is the resistance here? 5 ohms. That's why right here 5 ohms. What is the resistance here? 2 ohms. Here resistance is called 2 ohms. Right here, 2 ohms. This. Here resistance is called 20 ohms. Right here, 20 ohms. And here resistance is called 10 ohms. Right here, 10 ohms. So this is a dependent source. This depends upon current flow into the 5 ohm resistor. So that's why it's connected in series with the source. Okay, these terminals are connected in series. So that's why. So I'm deleting this here, this terminal, and connecting here this point to the here, and then next another terminal like this. Okay. Current enter, this is called 5 ohm resistor. No? Current entering like this and leaving like this. So that is called uh, I3. Here row is called 8 IR 3. Okay. And here, right here, what is that means? Trans resistance, that is equal to how much here? 8. 8. Then okay. So in this way we can we have to connect the circuits, and then so what is the find the voltage across the R3 in the circuit below. So where we have to connect the one voltage sensor. Find the voltage across the R3. Where is R3? Here R3. Okay. Voltage across the resistor R3. That's why one what is this one voltage sensor is required. Voltage sensor to measure the voltage sensor is required. This is called one voltage sensor. By using this voltage sensor, we can measure the voltage just like voltmeter. It acts as a voltmeter. Okay. Where is this resistance? Here, 5 ohm resistor. So here we have to connect the this voltage voltmeter exactly parallel. Okay, this is called positive terminal. Current entering like this. That's why we can connect here like this. And the negative terminal. In this way, we have to connect the voltmeter, that is called voltage sensor. After this, to measure this voltage across the current voltage resistor this R3, that is called 5 ohm resistor, one display is required to display the what is the voltage display. Connect display. So directly it cannot possible to connect. Okay, so not possible to connect because of this is called Simscape elements. These are the Simulink block. So that's why one PS Simulink converter is required. PS Simulink converter. By using this, we can connect it to the display. Okay, in between this, we have to place this in between. Okay, PS Simulink converter. Connect PS Simulink connector. This is called PS Simulink converter. And then, so this is same as this circuit is same as this circuit. Okay, this is called current controlled voltage source, and then simulate. Then it measure the voltage across the resistor R3 uh, by using different types of techniques. Nodal analysis or mesh analysis, we can measure the voltage across the resistor R3. That resistor and this practical resistor must be same. No change in difference. So that is voltage across this resistor 5 is nothing but 6 volts. Okay. This is called first circuit. Current controlled voltage source. Okay. The design and simulation of current controlled voltage source. Coming to the next voltage controlled current source. Voltage controlled current source, and take new drawing sheet. So here we have to simulate. Then what is this here? Current controlled currents. Current controlled current source. Current controlled current source. Current, voltage controlled current source. Voltage controlled current source. Right here, voltage controlled current source. Voltage controlled. Voltage controlled current source. Like this, voltage controlled current source. This is called voltage controlled current source. This circle is called as a source. And this plus minus is depends upon parameter that is called voltage depending parameters. This is called voltage controlled current source. What is the circuit here? What is the circuit? Here circuit is required one, two, three resistors and one voltage source. Three resistors and one voltage source. Take a DC voltage source. DC voltage source. DC voltage source. Open DC voltage source. Select this type of DC voltage source. And how many resistors? Three resistors. Three resistors is required. Okay, like this. Place this dependent source and resistors. Two resistors and here one more resistor. So three resistors here, two resistors. Press Control R. Connect this resistor to here and this resistor here. And this is called depending parameters, depending source. And take one this resistor, connect exactly parallel. Okay. So like this. This is called depending parameter. First connect this in this way, and the second is and here also. Connect here. So like this, one voltage source, 2 ohm resistor, 3 ohm resistor. And it's connected exactly parallel to current source is connected exactly parallel. This current source is connected exactly parallel and it also depends upon this resistance. So that's why I connect a current source exactly parallel like this. Okay. So current source is connected into the zone and is depends upon what? 6 ohm resistor. That's why connect these two terminals exactly parallel to this resistor in this way. It's depending on this resistor. No? That's why. So voltage source. That's why we have to connect it exactly parallel. If it is current source, we have to connect it in series. Okay. And what is the resistance? This 2 ohm resistor. Open right here 2 ohm resistor. And here also right 2 ohms. 2 ohms. And the next 3 ohm resistor. Right here, the 3 ohm resistor. And here right also 3 ohm. 3 ohms. And the next, what is this is called? What is the resistance here? 6 ohms. 6 ohms. That's why I change here, right here, 6 ohms. Okay. 6 ohms resistor. And also right here, 6 ohm resistor. 6 ohm. Okay. So place this resistor other side. 2 ohm resistor and the 6 ohm resistor. This is called our DC voltage source. And one solver configuration that is called solver configuration is required. Solver configuration. Solver configuration. Place here. and also one ground is also required. This is called our DC voltage source. 3 ohm resistor. This is 3 ohm resistor. And connect this solver configuration here. And take one electrical reference. Electrical reference. Electrical reference. Place this electrical reference here. How much voltage this DC voltage source? 6 volts. 6 volts. Apply, then close. DC voltage source, how much here? 6 volts. 6 volts. And next, open this transconductance K. What is that constant? Transconductance is called 2. Here 2Vx. That's why I write here 2Vx. Transconductance. Here 2. Then close. Okay, transconductance. So like this series connection is circuit connection is over. Okay. And then next, what is the question? The circuit dependent source, determine the voltage Vx. Determine the voltage Vx. So here also one voltage sensor is required to measure the voltage. Right here, voltage sensor. Voltage sensor. Connect this voltage sensor parallel to this resistor. Connect positive terminal to positive and the negative terminal here. And one, what is this here? One PS Simulink converter is required. PS Simulink converter. Connect this way. PS Simulink converter. And next one display is required. Display that voltage. Okay. So this is called display. And then simulate. How much of voltage here? Minus 3 volts. Okay. Plus minus 2Vx. 2Vx 3 volts. 2Vx here. Transconductance is called 2Vx. Yeah. 2Vx. Is depending upon this resistor. So 6 ohm resistor. And here what is the resistance? 2 ohms. 2 ohms. And here resistance 3 ohms. And our DC voltage source 6 volts. DC voltage source 6 volts. Then by simulating, here you are getting minus 3 volts across this 6 ohm resistor. So that means this polarity plus minus is reversion. That means meaning of this. Minus means here positive, here negative, opposite polarity. This is called voltage controlled current source. Next coming to the another circuit, current controlled current source. Current controlled current source. Current controlled current source. 2IY is called current controlled current source. Okay. Select new. Then open circuit. Current controlled current source. This current controlled current source. Current controlled current source. First, how many resistors? 2 resistors are required. 2 resistors are required. Resistor. Place here a controller and place here. Here also this 2 resistors, no? Okay, like this. 2 resistors are over. Next, this is called current controlled current source. Current controlled current source. Right here, current controlled current source. CU current controlled current source. Current controlled current source. This is called current controlled current source. In between Here we have to place a current controlled current source. In between, this is called voltage source, DC voltage source. So you have to connect here DC voltage source. DC voltage source we have to place here. DC voltage source. So plus control R. So what is the polarity of DC voltage source? Here plus and minus 2 volts. Okay. Plus here left side plus and right side minus. And open left side plus, right side minus, like this. Okay, this is called one voltage source, and also one current source is required. Right here, current source, DC current source, DC current source is required. Don't select this type of current source, DC current source, another type of current source. Open this DC current source, only constant current is. So place here control R. What is the direction of current? In this direction, right side. That's why, so it is also right side. Okay, this is the current direction. This is the resistors in between these two. Resistors are there. So connect first the resistor to this voltage source and the resistors to this current source. And connect here also the resistor to here and here, and current source is downwards direction. That's why this is called upward direction. That's why controller rotate downwards direction. Place here this dependent current source. How much resistance of this current source? 2 ohms. Here 2 ohms. Open this resistor. Right here 2 ohms. Okay. And here right here 2 ohms. 2 ohms. And what is this voltage source? Minus 2 volts. Okay, minus 2 volts. Right here minus 2. Okay. Here minus 2 volts. What is the value of resistance? 11 amps. 11 amps. Open. Right here 11. And DC current source 11 amps. Next DC next resistor no? 1 ohm and also 1 voltage controlled current controlled voltage source. Current controlled voltage source is required. Right here current controlled current controlled voltage source base here. What is the polarity of this current controlled voltage source? Positive upside, negative downside. Okay, so connect this here and another polarity connect. This is our connection, and what is the resistance here? 1 ohm. Resistance is equal to 1 ohm. Okay, by default this is 1 ohm. That's why no need to change. Here 1 ohm. So right here 1 ohm. Okay. What is the current source? 6ix. So that's why. And so then next connection depending. These are the two sources depends upon what? 6ix, for example, 6ix. It depends upon in this value of resistor. Upward direction, that's why the current ix is connected in upward direction. Okay. across the resistor. This voltage source is depends upon current, and current is called upward direction. Okay, so that's why remove your terminal, connect upward direction, current uh, first entering, current is leaving from the resistor and entering to the this source. Okay, current leaving and entering into the dependent source like this, and leaving from this dependent source and connected exactly parallel here like this. Current leaving here in this way, current leaving from 2 ohm resistor and entering to the dependent source. And what is the direction of dependent source? Downwards direction. That's why this current leaving and entering is same to the dependent source and connect here. Similar way, next what is this 2IY? It depends upon this 1 ohm resistor current downside. Okay, that's why current downside here, current leaving from 1 ohm resistor and entering into this dependent source. So like this. Okay, and enter like this, in this way. Understood? So current leaving from 1 ohm resistor and passing through the dependent source as same direction of dependent source, and then leaving to the ground. Okay. So this is connection. Then to simulate one solver configuration is required. Solver configuration. Place here. Solver configuration. Next one electrical reference. Electrical reference. Electrical reference. Place here electrical reference. For example, electrical reference I'm assuming like this here. Okay. So some cases also, if you can assume the electrical reference here, if you are placing this ground here, we will get different values of voltage current, and if you are placing this here, and you will get different values. So according to the ground, this current changes across the resistor. For example, if you want to measure the voltage across this 2 ohm resistor, take one current measurement. Okay, current source. Current measurements means here 1 meter current controlled current source across the that is called current measurements here, nothing but current sensor or voltage sensor. So I want to measure the voltage across the 2 ohm resistor. 2 ohm resistor, voltage across the 2 ohm resistor. That's why voltage sensor is required. Voltage sensor. Place here voltage sensor. Connect to positive terminal to the positive of resistor. Like this. Negative terminal to the ground like this way. Okay. And take one PS Simulink converter. PS Simulink converter. And connect this PS Simulink converter to this. And a display is required to what is the value of voltage. And this way we can connect the voltage measurement. If you want to connect the current measurement, also possible in series with this. Okay. So voltage, I want to measure the voltage across the 2 ohm resistor. That's why I'm connected here one voltage measurement, and then simulate. Simulate, and then what is the voltage across the 2 ohm resistor we can find. Okay. I am placing the ground here. That's why according to that we will get the voltage across the 2 ohm resistor here. If you are placing this ground here, and then that values are different. Okay, it is compiling. It takes some time. Okay, wait for some time.